Okay, kids. Alright, I gotta focus this thing. I'm gonna focus lock with my hand there. Perfect. Okay, so we did this practice thing in class. I'm going to explain it on a video. Alright, so for naming ionic compounds. Alright, so when we name these things, we gotta ask questions. The first question we have to ask is, when I name it, do I need a Roman numeral? And then how you know if the metal is in group 1, group 2, or group 13, then the answer is no, you don't need a Roman numeral. And then if the metal is in a different group, so I guess we could just say if it's in group 3 through 12, then yes, we do need a Roman numeral. I'll explain in a second how we determine that Roman numeral and what it means. The second question we have to ask: do we have a polyatomic ion in our compound? Well, if there are, I'm trying to think in real time how I could make this quicker, but whatever. If there are more than 2 elements, not more than 2 atoms, but more than 2 different elements in the formula, then that means yes. And then if there are only 2 elements, that means no. Alright, so remember, you are given the formulas for the polyatomic ions that you need to know. So once you determine yes, you just have to look for which polyatomic ion it is, either from its name or from the formula for going the other way. So our polyatomic ions are, there's 6 of them. 5 of them are anions, and 1 of them is a cation. The first one we have is called hydroxide. And the formula for hydroxide is 1O, 1H, and the whole ion has a charge of -1. So remember, the charge refers to the entire ion. Alright, the next one we have is called ammonium. It's not we will call it, that's just what it's called. And ammonium is a cation with 1 nitrogen, 4 hydrogens, and the ion has a charge of +1. Then we have carbonate. Carbonate is CO3 with a charge of 2-. Sulfate. Sulfate is SO4, also with a charge of 2-. Phosphate, which is PO4 with a charge of 3-. And finally, nitrate, which is NO3 with a charge of 1-. Okay, so we're going to refer back to this a lot. So let's get into it. Let me zoom in a little bit so you can actually see. Okay, so we have 5 sets here. 5 sets. This worksheet should be in your possession, but it also is in Schoology if you want to do additional practice. When we first did this in class, maybe you were a little bit fuzzy on things, but you have a better understanding now, so it might still be worth it to go through it. All right, now, we got names. We got to give the formula. If you're given the formula, you got to name it. Let me see if I can get another better focus here. All right, whatever. All right, so when we're going from the name to the formula, it's all about the charges of the ions. So potassium is in group 1, so its ion has a charge of +1. Oxygen, oxide is oxygen, it's in group 16, so it has a charge of -2. If you don't remember how we get these charges, go back to topic 3.1, because in 3.1 I had you draw a little periodic table which told you that the group number for certain elements will tell you what the charge is. So remember, the charges all have to be equal. They have to add up to 0. So if I add these two charges together, I would have to multiply that by 2. That means I need 2 potassium and 1 oxygen, so the formula is K2O. All right, calcium nitrate. So calcium is in group 2, so its ion is +2. Now you recognize the polyatomic ion because all binary compounds, now when I say binary, the ones that only have 2 elements, they always end in the 3 letters I-D-E. So I'd, and so forth. Well, 4 of our polyatomic ions, boop, 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 and boop, also all end in the 3 letters 8. So by looking at this name and seeing that it ends in 8, it tells me there's a polyatomic ion. Once you realize there's one of those, all you have to do is look at the little list, say which one is nitrate. Oh, it's the NO3 one, and its charge is -1. So this means I would need 2 of these to balance the charge. So 1 calcium, and remember, if there's more than 1 polyatomic ion, you have to put the formula in parentheses. Since I need 2 of them, we put the number 2 outside the parentheses, showing that we need 2. Okay, so now let's talk about that Roman numeral. The Roman numeral in the name means that it tells you what the charge on the metal is. So for certain metals, we know their charges because they're always the same, but for others, they could have more than 1. So we have to tell you what the charge is, and the charge is the Roman numeral. Iron 2 means that iron, in this case, has a charge of -2. Iodide is iodine. It's in group 17, so it's -1. Look at this. When we had a +2 and a -1, I needed 2 of the -1s, so that's the same case here. So 1 iron, 2 iodines gives me the formula. All right, so now we're going to naming. So when we're naming, we have to ask these questions. So the first question, do I need a Roman numeral in the name? If the metal's in group 1, 2, or 13, we don't. If it's in group 3 or through 12, we do. So when I look at this formula, I see CRS. The metal in there is chromium. So before we can name it, we have to find chromium on the periodic table to see which group it's in. Oh, it's right there in group 6, which means we do need a Roman numeral. So this is CRS. Now I'm going to do some work over here so you can see how we figure out what the Roman numeral is. Now remember, the positive charge always has to be equal to the negative charge. The nonmetals always have the same charge, so we can use their charges to figure out what the charge on the metal has to be. So S is sulfur. It's in group 16, so its ion is 2-. Now there's only 1 sulfur in that formula, so that tells me the total negative is -2. That means chromium has to be +2 in order to make the charges be balanced. +2 because there's only 1 of them. So when I name this, it's just chromium 2 sulfide. I almost wrote oxides. All right, so the next one, Mg3N2. Okay, first thing I got to do before I can name it is find magnesium on the periodic table. Oh, there it is in group 2, so we don't need a Roman numeral. I know that I don't have a polyatomic ion because there's only 2 elements, magnesium and nitrogen. So when I name it, I just write the name of the metal, magnesium, and then the name of the anion that's made from nitrogen, which is called a nitride ion. So this is just magnesium nitride. All right, next one, RbOH. Before we can name it, we have to find rubidium on the periodic table. There it is in group 1. It's in group 1, so we don't need a Roman numeral. Next question, do we have a polyatomic ion? If there are only 2 elements in the formula, no. If there's more than 2, yes. So if we look here, I've got 1 rubidium, 2 oxygen, and 3 hydrogen. Once you realize there's a polyatomic ion, we just have to figure out what the name of the one that's OH is. Oh, the OH is called hydroxide. We don't need a Roman numeral for rubidium, so this is just called rubidium hydroxide. Okay, so I want you guys to take a minute, pause the video, and then try set B. And then I'll come back and give you the solutions. Okay, I'm back. All right, so first things first, nickel 2 sulfate. When you're writing the formula, if there's a Roman numeral, it means the charge on the metal. So nickel 2 means nickel is +2. Sulfate ends in 8, so we know it's one of our polyatomic ions. Sulfate has the formula SO4, and it has a charge of -2. Hey, look at that. The charges are already equal and opposite, which means I would just need one of each ion. So one nickel, one sulfate, which is SO4, so it's just NiSO4. Okay, next one, beryllium phosphide, ide. Beryllium is in group 2, so its ion is +2. Phosphorus, which is what phosphide comes from, is in group 15, so it's -3. Now remember, whenever you have one thing that's 2 and one thing that's 3, in order to balance it, you need to multiply the thing that's 2 by 3 and the thing that's 3 by 2. That means I need 3 beryllium and 2 phosphorus, so it's Be3P2. All right, manganese 3 oxide. That 3 means manganese here is +3. Oxide is oxygen, which is -2. Uh-oh, we have the 3 and 2 again, so that means I need 2 of the 3s and 3 of the 2s, so this would be Mn2O3. All right, now for the naming. Before we can name, we got to find the metal on the periodic table. Na is sodium. It's in group 1, so we do not need a Roman numeral. There's no polyatomic ion here, so we just call this compound sodium. F is fluorine, so sodium fluoride. Ooh, this one looks tough, huh? Yowza. Let's see. Before we can name it, we have to find CO, which is cobalt, on the periodic table. Ooh, it's in group 9. That means I do need a Roman numeral. If I look, I have 1, 2, 3 elements, which tells me that that is a polyatomic ion. So we have to go back and look at our list of polyatomic ions to see which one is PO4. So that one is called phosphate, PO4. It has a charge of 3-. So if we look here, and I'm going to zoom in, there's 2 phosphates. That's what that 2 means. Each one is -3. Since each one is -3 and I have 2, then the total amount of negative charge is -6. 2 times -3 is -6. Well, that means the total positive has to be +6. But since there are 3 cobalt, that means each one would have to be +2. Take that 2, bring it up there, and it tells you what the charge is. So this will be cobalt 2, because the charge is 2. Phosphate, because the anion is the phosphate ion. All right, number 6, VO2. Before you can name it, you got to find vanadium on the periodic table. There it is in group 5, which means we need the Roman numeral. Now we don't have a polyatomic ion here because there's only 2 elements, so this will just end in oxide for the oxygen. But we need to know what the charge on vanadium is so that we can stick it in the name. So each oxide ion has a charge of -2, and there's 2 of them, so my total negative is -4. Remember, when I add the positive to the negative, it's got to add up to 0, which means the positive charge has to also be 4. Since there's only 1 vanadium, the whole thing will be +4. So this is vanadium 4 oxide. Okay, so I'm probably going to do one more set and then stop, because we don't do anything different in any of the sets. It's the same thing every single time. So the more you do it, the better you'll get at it. Eventually, you'll be able to do it correctly every single time because you will have learned how to do it. All right, so let's do the formulas. Ammonium. This is a bit of memorization because you have to remember that ammonium is one of our polyatomic ions. It's 1H, 1 N, 4 H's with a charge of +1. But for this, the formula writing, we only care about the charge. It's +1. Bromide comes from bromine, which is in group 17, so it's -1. Since the charges are already equal and opposite, I only need 1 of each ion, so this would be NH4Br. Just to expand, if it was ammonium oxide, ammonium is +1 Oxygen is -2. In that case, we would need 2 of the ammonium ions. So ammonium oxide would show the ammonium ion in parentheses with the 2 outside and the O outside. All right, moving right along. Aluminum chloride. Aluminum is in group 13, so it's +3. Chlorine is in group 17, so it's -1. The charges have to be equal, so I need 3 of those -1s to match the 1 plus 3. So this would be AlCl3. Okay, let's keep on going until the end of the set. Now, just so you know, the key to this is also posted in Schoology, so you can go through set D, go through set E, check the key, see how you did. All right, so copper 1 means copper here is +1. Carbonate ends in 8. Once you realize there's a polyatomic ion, you just have to look at what the formula for and charge of carbonate. The formula is CO3, and the charge is -2. So I got to make the charges equal. That means I need 2 of those copper to equal the charge of carbonate. So it'll be Cu2, CO3. All right, the naming bit. Before you can name it, you got to find SR on your periodic table. Oh, there it is, strontium in group 2. So no Roman numeral needed. No polyatomic ion because there's just 2 elements. So this is just called strontium nitride. Next, before we can name it, you got to find the metal on the periodic table. We've already looked at this one. Sodium is in group 1, so no Roman numeral needed. You'll notice we have a polyatomic ion because we have 1, 2, 3 elements. So I got to find what the name of the polyatomic ion that's NO3 is called. And, oh, right there it is, and it's called nitrate. So this is just sodium nitrate. And the last one. Before I can name it, oh, you know what I'm going to say. We got to find Mn on the periodic table. Manganese. Manganese. There it is. It's in group 7, so we need a Roman numeral. Do we have a polyatomic ion? Yes, because there's 1, 2, 3 elements. So now I got to go and find what the polyatomic ion that's SO4 is called. Remember, you will always have access to these names and these formulas, so make sure you use them. It's SO4. The charge is -2. There's the SO4. Since the charge is -2, there's 2 -2s, which means the total minus is -4. Oh, we've done this before. When I add the positive charge, it's got to equal 0, so that positive charge must also be 4. So this would be called manganese 4 sulfate. All right, kids, do yourself a favor. Over the break, try to do some practice. We're going to have one more class to review, and then we're going to take our test on this. Do well on it. For yourself, not for me. Do it for you. And have a lovely Thanksgiving break.